Welcome to The Explainer. I am so thrilled to have you here today. Get ready, because we're about to unravel a true detective story of the cosmos. This isn't just about finding some random planet out there in the dark. It's really this profound story of how human ingenuity used the absolute subtlest of clues to solve a monumental mystery, literally billions of miles away.
Okay, let's dive into this. Imagine you're looking up at the night sky. You're meticulously tracking a planet, and suddenly you notice something just isn't acting the way it mathematically should. Well, that was exactly the central mystery that completely baffled early 19th century astronomers. Uranus, which was the outermost known planet at the time, was wobbling.
Section 1. A Celestial Mystery.
So let's look at how this timeline actually unfolded. Uranus was first discovered by William Herschel back in 1781. But by the early 1800s, astronomers started noticing these small, highly unusual changes in its orbit. It was drifting. Now think about how absolutely confounding this must have been for scientists at the time, right? The trusted, universally accepted laws of gravity established by Isaac Newton simply could not explain these rogue movements. The other known planets definitely weren't causing it, so it looked like Newton's trusted laws were just breaking down. This became a massive, unprecedented celestial puzzle that demanded an answer.
Section 2. The Mathematical Prediction.
Now, what's really interesting about this slide is the incredible parallel thinking going on. We have two brilliant mathematicians, John Couch Adams in England and Urbain Le Verrier in France. And working completely independently of one another, both of these men decided they were going to catch this gravitational culprit, but not with a telescope. No, they used a pencil. They used those very same laws of Newtonian gravity to calculate exactly where an unseen, totally invisible planet had to be located in the vastness of space to pull Uranus off its path.
And here is the deeply satisfying payoff to the whole mystery. Le Verrier sent his final, meticulous calculations over to Johann Gottfried Galle at the Berlin Observatory in Germany. And on the night of September 23, 1846, Galle pointed his telescope exactly where the math told him to look. Within a remarkably short time, he spotted the target. It was almost exactly where Le Verrier said it would be. No way, right?
Neptune was literally predicted using mathematics before anyone had actually seen it. The absolutely crucial point here is the staggering power of the scientific method on full display. This wasn't some lucky accident or a random sweep of the night sky. Not at all. It was a monumental achievement for astronomy, proving once and for all that pure math and logical deduction could uncover completely unknown, invisible worlds hiding out there in the dark.
Section 3. An Extreme Ice Giant.
First, let's just try to grasp the sheer scale of Neptune. Coming in at a massive 49,500 kilometers in diameter, this ice giant is about 4 times wider than our own Earth. To put that into perspective, it is a hulking, frozen behemoth that commands the outer edge of our solar neighborhood.
Let's see how this builds our understanding of its visual profile. That gorgeous deep blue appearance? It's not an ocean. It's simply the result of methane gas in its atmosphere, absorbing red light and reflecting blue light right back into space. The atmosphere itself is this thick, incredibly turbulent, swirling mix, composed mostly of hydrogen, helium, and of course that color-shifting methane. But hey, do not let that calm blue exterior fool you for a second. 2,000. The winds on Neptune whip at over 2,000 kilometers per hour. Those are the fastest, most violent planetary winds ever recorded anywhere in the solar system. It's truly mind-boggling when you think about it. Actually, scientists are still trying to figure out how such phenomenally powerful storms can even exist so incredibly far away from the heat and energy of the sun. And speaking of being incredibly far from the sun, let's ground these massive numbers by relating them back to our daily lives here on Earth. It takes a grueling 165 Earth years for Neptune to complete just a single orbit around our star.
Which leads us directly to this absolutely mind-blowing fact. Because its year is so incredibly long, since its glorious discovery way back in 1846, Neptune only completed its very first full orbit in the year 2011. Yeah, you heard that right. For over a century and a half of human history, it was just slowly making that one solitary trip around the sun.
Section 4. Moons, Rings, and Legacy.
Now, Neptune is definitely not alone out there in the dark depths of space. The planet boasts a busy, highly complex system of at least 16 known moons, all firmly caught in its gravitational grip.
The largest of these moons is Triton,
And this brilliantly illustrates just how dynamic and chaotic the early solar system was. You see, Triton is highly unusual because it orbits Neptune completely backwards, literally in the opposite direction of the planet's rotation. This retrograde orbit tells scientists that it definitely didn't form peacefully alongside Neptune. Instead, it was likely a rogue, wandering world violently captured by the ice giant's massive gravity a long, long time ago.
And it hides one more beautiful secret. While they're not nearly as famous or brilliantly visible as Saturn's, intricate spacecraft observations have confirmed that Neptune also hosts a faint, delicate system of rings. These are made entirely of dust and ice particles, just quietly circling the planet out there in the dark. So, what does this all mean? The discovery of Neptune remains one of the absolute greatest examples of scientific reasoning in human history. They mathematically proved it should exist, and then they looked up and found it. So I want to leave you with this provocative question to chew on. If math can find a hidden planet, what other invisible mysteries is our universe hiding right now? Thank you so much for exploring with me on this explainer. Keep asking questions, and I'll catch you next time.